Hello guys, this is a demo for our new project TikTok clone. Before I start, this is a small introduction about myself. My name is Yazan Yahya. I am a senior software engineer with over than 5 years of experience, mainly focusing on the backend development. This project involves building a full stack short form video sharing platform where users can upload and share videos, like, comment, and favorite videos, receive personalized recommendations based on their interests and interaction. This is a screenshot from my application. Objectives and impact. Uh, our first objective is to create an engaging user experience by providing a seamless video sharing and discovery. Also, we are focusing on smart recommendation by improving user retention and with adaptive feeds. Technologies used, I used Next.js as a front-end backend solution, Clerk as authentication and user management, Upstash used as a Redis cache, Gemini used for embedding text and also summarizing videos, Cloudflare used as basically R2 as to save the videos, upload the videos, and our database is a SQL Postgres database with a Drizzle as our ORM and Neon as a serverless database. This is a high-level system architecture. Uh, we have the user. The user basically interact with our frontend, which is React or Next.js, and also Clerk use as authentication. Next.js also can be used as a backend, so we have a backend here. The backend interact with Cloudflare R2 to upload videos, and also I am running Python code as a cron job every 3 minutes that read the data from Postgres and also store data or recommended videos in the Redis cache. Our backend reads data from database and also from the cache and return the data to the frontend. User onboarding flow. Once the user accesses our site, if the user is not signed up, the user will see a sign up form from Clerk where the user can sign up. And once the user is signed up, a webhook will be called in our backend from Clerk with the user ID and information. This data can be saved in our database. And if the user is not onboarded, based on metadata is saved in the session, we allow or we show the onboarding page to the user where user can select their interests. These interests saved in the database, and we are using the interests also to embed the data. We are using the interest to embed the user profile. So we are using Gemini model. We are sharing the text. This one user is interested in with a Gemini model and return the embedding as a vector, and this saved as embedding for that user. After that, we are making the onboarding flag as true on Clerk as metadata. Upload video. The flow starts when the user selects a video. An API will be called in our backend. Our backend will call Cloudflare R2 to save to upload the videos and save it. The video URL will be saved in the database and video record will be added, and a successful message will be returned to the front end. After that, asynchronously, we are calling Gemini 1.5/1. We are sharing this prompt to generate a summary and also interest of the video. And we are using the output, which is the summary and interests, and share this output with Gemini again to embed the text and save the embedding vector in database as embedding of the video. This embedding can be used later on in the recommendation engine. Recommendation system. This is how the recommendation system works. We have the user. The user will see the feed page. So we are calling an API in our backend. Actually, the recommendation system consists of two parts: content-based filtering and collaborative filtering. The content-based filtering is based on the user embedding and also video embedding. So we are applying cosine similarity between user embedding and video embedding, and return the most match similarity between user and videos. As I said, we have a cron job which runs every 3 minutes that reads the data from the database and applying collaborative filtering and saving the data to the cache. And after that, in the feed API, after fetching the content-based filtering recommendation videos, we are also fetching the data for collaborative filtering from the cache and merging both together, the content-based and collaborative filtering, and return the data to the frontend. But before that, we are doing some adjustments on the scores. Here, key factors affecting recommendation scores. The first one is score adjustments by merging collaborative and content-based filtering. The collaborative filtering involved on or based on past user interaction, likes, watches, and watch duration. Content-based filtering based on video similarity, the summary and embeddings. Final score is collaborative filtering multiplied by 0.7 plus content-based filtering multiplied by 0.3. I'm giving more priority here to the collaborative filtering because it represents the short-term recommendations, while content-based filtering uh, represents the long-term recommended videos. The second adjustment is time decay factor. Recent interactions matter more, so older interactions should lose weight over time to keep recommendations fresh. So, for example, if I watch the video today and I have a score 5, if I'm watching it after 30 days, the score should drop to 3.2. So I'm taking into consideration the interaction date when adjusting the scores. The third adjustment is diversity control, avoiding over similar recommendations, reduce scores for videos too similar to already recommended ones. Here's the formula: adjusted scores equal original scores minus similarity to the previous multiplied by penalty. So, for example, video A highly similar to the watched videos or to the previous videos, then I have to reduce it, for example, by 20%. Video B is less similar, so keep it, don't update the scores. This ensures variety in recommendations to increase engagement. You can think of it like we are iterating over each video, and we can check the similarity of the video against the average or the accumulated average of the previous video. If the similarity is greater than the average within the threshold, within the given threshold, we have to add the penalty here based on the similarity to reduce the weight, so to have more variety in the recommended videos, this to increase the engagement at the end. Now let's go to the demo. Here I'm using Clerk, and I already am using two users. What I will try to do here is to change the onboarding to false so we can see the onboarding page. This data is used as a session data and can be used to redirect the user to the onboarding page. So as you can see here, it automatically redirects the user to the onboarding. Okay, now let's say I will choose sports, food, and travel and get started. This data will be saved and embedded and also saved. So if I check the feed API here, I can see here is the recommended videos. For each video, we have the score and also see if this one is collaborative or content-based. We can see that this video is the highly recommended one because it is both collaborative and content. Yeah, you can see, for example, this one is collaborative. Okay, and the score of each videos. I think
vertical farming is a 21st century.
Get up! Get up! Alright! It does not matter how many times you fall in this.
Okay, now I want to log out to try different one. Since I'm running it locally, this one will fail. No problem. I am switching to another user. This one has food, fitness, I think, and technology. So yeah, I'm seeing different videos here.
Vertical farming.
Okay, now let's take a look on the database. This is our database. I have basically three tables, but it can be improved, of course. In the user profiles, we have the ID of the user, which is Clerk ID. These are mock data I created to see the behavior of the recommendation system. And also we have the email, the profile picture, and the interests. Also the embedding of the interests as well. I have the videos. Also, these data are generated. I wrote this script to generate random videos and also random interactions. For example, this is a video, this is the summary, this is the interests or categories, and this is the embedding, and also we can see the user who uploaded the videos. Yeah, here I have an example to show you how collaborative filtering work. This is a video with ID 22, which is recommended for this user. Okay, yeah. So this is the user has the user ID is this one. Okay, so I want to see why they recommended 22 for me. So I search for interaction. I see that the user Alice, this one, watched the video 2 times with 233 seconds 2 times. So it's likely to see, it's interesting to see the behavior of user Alice against my user. So I search by user Alice in the interaction, and I see that they watch 21, 21, 22, 23, 24, 25, and also search by the interaction of my user. I noticed that there is a similar behavior because I watched 21, 23, 20, 23 2 times, 24, 25, 26. So we have a similar behavior between my user and also this user. So it's likely so I'm likely to like 22 video because user Alice watch it and there is a common or similar behavior between them. I have Redis cache, the Python code, run and save the collaborative filtering scores for each user. So for each user, I updated the data every 3 minutes with this is the recommended videos, the 5 videos with the score from 5. Yeah, that's it basically.
ركزوا بالنظارة.
Thank you for watching.
هذه تقنية التين